Hi everyone, let's work on question 10 in topic set 8. This is a question about Lewis structures, so it's just asking to draw a bunch of different Lewis structures that happens to obey the octet rule in this case, so none of these things will violate the octet rule. And once we draw all of these, you're supposed to think about what conclusions you can draw based on the Lewis structures. So if you look at part A, we'll start with the first one, POCl3, and just remember with Lewis structure, we start with the valence electron. In this case, we have 5 phosphorus, 6 for oxygen, and then 3 times 7. So we end up with 32 electrons. And we just start drawing. We start with our central atom. This is a structure that satisfies the octet rule. So we just need to make sure that everybody has octet in this case. And right now I've used up 4 electrons, so let's put octet for everybody. I'm just going to use lines here to represent a pair of electrons. So if you count all of the electrons right now, each atom has 4 in the outer end, and 4 times 4 is 16. 16 pairs times 2 is 32 electrons, so we've used up everything. So that will be the structure for POCl3. Let's try sulfate. Valence, we got 6 plus 4 times 6 for oxygen. Got a charge of 2 negative, so 2 more. This also add up to 32 electron. You might start seeing a pattern here. If I draw the structure, sulfur in the middle, O, and again I would put all these pair of electrons around the O. You notice that would use up all the electrons. There's 32 electrons now across, which means we have used up everything, 2 negative outside. Okay, let's take a look at the third one, XeO4, 8 for the Xe, 4 times 6, that's 24, 32 electron again. Okay, so hopefully that pattern becomes more and more obvious now. Xe, 4 oxygen around it, 1, 2, 3. Hopefully you also see a pattern here in the drawing itself, the Lewis structure of the 3 structures we drew so far. They're very similar. In fact, that's the conclusion that we'll draw later. But let's finish up with the other 2 structure, phosphate. As you might guess, this is also going to be 32 electrons. Same structure, phosphorus in the middle, getting 32 electrons in the end. This is an ion, so 3 minus. And then we have perchlorate ion, 32 electrons again. So here's 1, 2, 3, ion, and voila. So all those structures have been drawn now for the part A species. Now we can go to part B. Okay, just gonna draw a line here, and let's go to part B. So in part B we have 3 species. I'm just gonna write it here for now. And if 3 is 1, then we also have sulfite, PO3 3 minus, phosphite, and then ClO3 minus, chlorate ion. Okay, and let's count the electrons here. We got 5 plus 3 times 7, end up being 26 electron. And drawing the structure show us that it would look like this: 1, 2, 3, and again you always make octet from the outside first. You do that, you have 4 times 3, which is 12. 12 pairs is 24 electrons. You still have 1 more to place, and of course you place that at the nitrogen to make it octet. So that's your structure. Now if you go with sulfite, you have 6 plus 3 times 6 plus you got 2 more electrons from the charge. That also ends up being 26 electron. And again, you start seeing the pattern, hopefully. 3 here, 1, 2, 3, 5, 6, 7, 8, 9, 10, 11, 12. So again, missing 1. We put that last one over there. That's your sulfite structure. Phosphite, you can count it. It'll be 26 again. And again, you should start seeing also the pattern in the structure that I'm drawing here for this ion compared to the other 2 that we just drew. Then lastly, another 26 electron, ClO3, and that. Okay, so that's for the second one, part B. Let's do one more here on the side for part C. In part C, we only have 3 species. We got ClO2 minus, and then we have SCl2, I'm going to use here, and then we have PCl2 minus. Okay, let's count up what our electrons are. We got 7 plus 2 times 6 plus 1. Ends up being 20 electrons. So drawing that out, we got O and O. Then again, making octet for the outside, you got 4 times 2 is 8. 8 is 16 electrons total. 18, 20. So that's your ion there. This one, no surprise, you'll count and find that it's 20 electrons. SCl2, and that would work out like that. And then lastly, this one also 20 electron, PCl2. If you work it out, you're gonna get a structure that looks like that. Okay. Now, so the question at the last one is, what's the conclusion that you can draw if you look at all these structures right here, specifically about species that contains the same number of atoms and the same number of valence electrons? Because that's what's been going on here. So if you look at all the species in A, they all have 32 electrons, and look at their number of atoms. They all have 5 atoms, right? You look at the second set of species, they're all 26 valence electrons, and look at how many atoms they have. They all have 4. Okay. Then if you look at the last one, all of them have 20 electrons and 3 atoms. And what's interesting is if you look at the Lewis structure, they all have exactly the same Lewis structure. For this one with the 32 electrons and 5 atoms, 1 central atom in the middle and 4 around. If you look at the one with 4 atoms with 26, 1 in the middle, 3 around, all octet, right? So that's the conclusion that we're going to draw, is that given a specific number of valence electron and atoms, the Lewis structure will be identical. Okay, so just a quick example. Let's say your structure is AX4 with 32 electrons, so that would match with the first species here, the one with question A. So automatically you would expect to see something like this. So you don't even have to think about it, in other words, to get your structure. Now that could be an ion, it's not necessarily this, right? So say this is an ion with charge N, for example. Then if it's an ion, then it would be N here, but if it's a molecule, it would just be 0, the N would be 0, so then you would remove the bracket. But that would be the structure. Okay, so that's the conclusion you can draw about Lewis structures in general that satisfy the octet rule.